If it's any very important customer, let them in. It's fine.
No, these are my coworkers.
OFC 2026, many companies had very strong press releases just before the conference. We want to see, we want to touch the technology here. So I'm with Brad Booth, the CEO of NLM Photonics. Brad, thank you very much for having me. We are at the private room of NLM.
We are.
At the back of the exhibition of OFC. What did you bring?
What did I bring? Well, I brought devices, a 1.6T device that we're running data through to actually show that we can run data through our 1.6T PICs. We are also showing our 1.6T PICs and our 3.2T PICs that are ready for customer sampling. We're also showing a device that we did with Tower. So we actually did an MPW run. We did the oxide open etch in-house. We have access to a nice fabrication lab. And we did deposition of our material to actually show that you can build a modulator with Tower's silicon photonics process.
Brad, I don't give compliments easy. I had to give you one. Collaboration have been the success of NLM.
It has.
What is NLM Photonics today?
Where are we today?
What is it? What is
it? So NLM Photonics is really creating a blueprint or a recipe for the industry to be able to use. Our goal is to actually transfer our intellectual property into the ecosystem so that anybody coming along that says, I want to be able to use NLM's cross-linkable organic glass can go to a foundry or go to a design house, and that is already made available to them. So we're building out the ecosystem all the way from the material with working with companies, our investor like TOK, who makes photoresist. They're working to develop an ink that the foundries can use. We're working with foundries like Global Foundries, Tower, AIM Photonics, and a couple others to show that the technology can be built in those foundries and be fabricated by those foundries.
Brad, from the passenger seat, what I can tell you is that for many years, we want to test this organic glass. We wanted to see how it works. We wanted to see if it works. And it was almost impossible. You go to the companies providing this material, and it was material, but not chips.
Yeah.
Now you can get chips.
Now you can get
And now
chips.
you can do this collaborating with foundries. Did you bring any of these sample chips that we could get?
We have one that we're demonstrating here. This is on an evaluation board. Our goal now is to actually start making those available to our customers. Customers can either use it as a PIC or they can get it on an evaluation board. We are working to do the same thing with 3.2, but for the 3.2T devices, we're actually going to put all the driver circuitry and components necessary. Not everyone has the test equipment to be able to do the type of work to probe a 3.2T PIC. Some do, and so if they want raw PICs, I can give them raw PICs. If they want the evaluation board, they can get the evaluation board.
The industry is talking a lot about narrow and fast or broad and slow.
Yeah.
Where do you stand?
Well, it's interesting coming out of the tech industry for such a long time working on connectivity. Wide and slow is great, but I tell people there's usually a trade-off. You can only go so wide before you have to run into challenges. So it's going fast is challenging. What we're showing is, hey, I can go to 200 gig on silicon photonics. I can go to 400 gig on silicon photonics. And later this year, we're hoping to prove to people you can go to 800 gig on silicon photonics. So we want to show the industry that there's a path forward. It's not going to be in your traditional silicon photonics. It's going to have to be a silicon organic hybrid. But if you're willing to bank on silicon organic hybrid, I can take you to higher bandwidths.
Brad, you're talking about 200 gig per lane, 400 gig per lane. It all goes down to the speed of the modulator, the speed and reliability of a low VPI modulator. What is the fastest modulator you can make?
You can actually go into the terahertz range with organic materials. A plasmonic modulator, for example, like Polariton makes, goes into the terahertz range. We haven't found the top end yet on silicon organic hybrid. We're currently pushing to see about doing 800 gig. Honestly, I don't even have components to drive 800 gig. So I'll have a device, but I'm going to have to figure out how to get components to drive it. So we're already trying to show that there's nothing that's limiting the photonics. And what drives that design is the size of the modulator. So this is the aspect with organics, is that you actually go down in size to go up in performance. Completely opposite of what you traditionally do. Normally, you go up in size to get more performance, which means you go up in power, which means you go up in cost. We're going the other direction. We're going up in performance, down in size, down in cost.
One thing that was very clear in your press release and also at your announcement at the Executive Forum, you have the demo kit. And it's the second day at OFC. You had lots of meetings.
Yes.
What are the key questions your customers or potential customers are asking you about this demo kit? What do they want from it?
They want to know when it's going to be production ready. And our goal, we're working with our partners to have this production ready, commercial high volume production ready by late 2027, early 2028.
I also have seen in the nature of collaboration that you're working with design houses like Spark, Innosemi, with foundries. Can you tell us how this supply chain look like? If I want to get an organic glass-based chip, how do I do it?
Today, the way you would do is you would work with us. But the goal is in the future, you will go to your foundry of choice or your PIC design house of choice and say, I would like to use this technology. I want to do silicon organic hybrid device, 3.2T, 6.4T, whatever you want. And they would have that already built into their fab process line. The material would be provided by large material providers, and the PIC design houses would know how to work with it. And it's actually very easy for most of the PIC design houses to be able to do the designs. We've had no issues transferring between PIC design houses. It's just a case of what PDK are you using at the foundry?
I'm scared of the world future, Brad. So when can we have a PDK with organic glass on it?
Oh, our goal is to have production-ready PDKs getting ready by the end of this year, early next year.
Oh, wow.
And that's production quality. That's not just your design PDK. That's the foundry PDK and the design PDK made it together to be able to be
It is very
used.
clear with the foundries that you're working. We are talking about foundries like Tower and like Global. You have to be production ready to even cross the line.
Yeah.
One thing that for me is very important, in 4 years from now, let's play the crystal ball game. How does NLM Photonics look like?
So in 4 years, the way NLM is playing this forward is our goal is to eventually build our organic materials into the full manufacturing process, such that we handle the high temperature manufacturing. And what that allows you to do is actually closely integrate the silicon organic hybrid technology next to the electronic circuitry. So there's not that separation of a PIC and an EIC. Those two actually become a merged element.
For those early adopters that until now are still considering the challenges on reliability, manufacturability, that's your camera. What message do you have for them?
I would say, take a look at the technology, come and talk to us. You will be surprised what we can do and what my team has been able to do.
We finally can try, we finally can use, we finally can test organic glass-based photonic integrated circuits. Thank you, NLM Photonics. Thank you, Brad Wood.
Thank you, Jose. Good seeing you.
That was awesome. That was very nice. I liked it.